All right, so in Chapter 9, Section 1 was dealing with population proportions. In Section 2, we're dealing with population mean. So very similar to the previous section, except how we compute the values. A little different, or we'll use StatCrunch a little differently. So there's a question here that says, determine the point estimate of population mean and margin of error. So just understanding that it is some idea of some p-hat plus or minus some margin of error. That's what a confidence interval is. So if I have my lower bound and upper bound, the point estimate is going to be the number in the middle, because it's you have a p-hat minus c, or in this case a sample mean, an x bar minus a margin of error, and then you have an x bar plus a margin of error. So your point estimate is going to be right in the middle. So in between 21 and 29 is 25. The margin of error, that's how much you have to add or subtract. So to go from 25 to 29, it's 4. To go from 25 to 21, it's 4. So that's my plus or minus. That's my margin of error. So just wanted to talk about just kind of a little bit of an understanding of the formula, but understanding what it's doing. The next one I want to look at is number 7. And in number 7, it's talking about some ideas of what's happening. Recommendations for decreasing the margin of error. So if you want to have a better guess of your population parameter, in this case our population mean, if we want to get a better things, what could be the things that we would give it better answers? I don't think decreasing the sample size. Maybe increasing the sample size would do it, right? Because if I have more people, I'm going to get a better guess at the population mean. So degrees of freedom we're going to talk about in a minute. Decrease the confidence. Well, if I decrease the confidence, that does mean that my interval could get smaller, right? Because I don't have to be as confident, so I can make a smaller interval. So decreasing the confidence would make my interval smaller. Increasing the confidence would make it go way out, right? Decrease the standard deviation of hours worked. And so knowing how the formula works, you're dividing by your standard deviation, or no? I don't think decreasing the standard deviation is going to do it. I think it's decreasing the confidence interval and increasing the sample size. So let's check it real quick. And good. So those are the two things that are going to help us decrease our margin of error, which is decreasing our interval. One that's kind of going to be worked through is number 11. I think it has several parts. It gives us some data, so we'll have to download the data to StatCrunch. So we need to view the data for first sample and second sample. So we have two different samples that we're looking at. And I'm going to go ahead and open that in StatCrunch. So, but the first thing that it's asking is that from the first sample, compute a point estimate for the population mean. So that's just my best guess. So that's going to be my sample mean, is my point estimate. So my data should be coming up. And again, if I just want to find my point estimate of my population mean, my point estimate is my sample mean. So we could just go to our summary stats of this particular column, and it should give it to us pretty easily, right? So that's something that we did in chapters long ago, figuring out a sample mean. But it is recognizing that that is our point estimate, 4.424. 4.424. And sweet. Next part of the question, make a 95% confidence interval for the population mean number of shares traded per day in the certain year. Interpret the confidence interval. So with this one, like here's my data, and if I'm doing a confidence interval on means, so here's the thing that's different, and I'll explain this after this question. We're going to go to t-stats. I'm going to do one sample, and I have the data. My data is in var 1. Right, that's where all our data is. I want to do it a confidence interval and a 95%. So I don't have to tell it anything. It does the counts. It knows everything. And I get this lower limit and upper limit. Notice it does give me this degrees of freedom, which again I'll talk about in just a second. So I got a 3.901 and a 4.947. I can remember at least one of those. 3.901. I'll have to pick which one it goes into. So looking at which one. So this one says for all days, but we're looking on traded on a given day, right? And so maybe it should be on the stock traded per day in the specified years between these values. So I like this one. Going into it, it's a 3.901. And this one over here is at 4.947. And again, and we said 95% confident. You don't want to say probability, you want to say confident. So it was in between A or C, because it says all day, but this is on a given day. So that's why I chose C. Make sure, yep, 95% confident per day in that certain year. So I'm feeling really good with C. Let's check our answer. And it gives us the high five, hopefully. High five. Now, so with this one, again, we had the data. So we need to make sure that we realize that we had the data. And so we went to stats. We went to t-stats, one sample with data. So that's a little bit different. If we just had a summary of data, we would type it in there. So this T, depending on the sample size, and if we don't know certain things about the distribution, or the population, we don't know the population standard deviation, or maybe we don't know if it's normal or not, we can use this T calculator. It's very similar to the normal calculator, except we need to know degrees of freedom, which the only thing degrees of freedom is your sample size minus 1. So if I had a sample size of 20, my degrees of freedom would be 19. So we're just subtracting 1. And then we're trying to figure out this T value if it's less than 1. Right? So here's 1, and we're looking at those numbers to the left. So it kind of looks like the normal distribution, the standard normal with 0, 1, 2, 3 for standard deviations. But this one's dependent on our sample size. So typically it's used for smaller sample size. The guy who came up with it actually was a guy who worked for Guinness. So interesting story. But this is our T distribution that we'll be using with sample means. Sample means. One more from the homework. The rest are maybe dealing with the second sample. So I wanted to look at one more problem. And it was number 13. So this one was dealing with subjects, right? So a sample size. So we're going to do that similarly to what we did previously. A doctor wants to estimate this for 20 to 29-year-olds. He has a sample standard deviation of 19.4 within 4 points. So that's my plus or minus within 4 points and 99% confidence. So margin of error is plus or minus 4 points. My sample standard deviation is a 19.4, and then a 99% confidence. So I'm going to go over here, and I'm going to go into my stat, my t-stat, one sample, width, and sample size. So it's going to ask me for certain things. I think it was 99% confidence. My standard deviation was 19.4. And then my width said plus or minus 4 points. So these aren't percentages, these are points. So plus or minus means 4 to the left, 4 to the right. So I have a width of 8. And that will give me my sample size needed, 160. So I can come over here, type in 160, and I'm good. So hopefully this will help with some of section 2.